Okay, we're looking at mixed exercise 10 on trigonometry from the first year core textbooks. We're looking at question 5 where we've got to just simplify these expressions. And so looking at 5a, you're pretty much guaranteed when you get this type of trig question that it's going to be using the identities that you've learned this year. So you've got tan theta is equals sine theta over cos theta, and sine squared theta plus cos squared theta equals 1. So there's no mention of tan in this one, and I've got powers, so I'm thinking that this is going to be the useful identity. And you don't need to prove this identity, but you do just need to know it and spot when to use it. Now, there's actually two ways I could tackle 5a. One is, so let's write the original expression out they want me to simplify. So if you spot that you've got the difference of two squares there, as in, so because cos to the power of 4 is a square and sine to the power of 4 is a square, you can just rewrite that as cos squared theta minus sine squared theta times cos squared theta plus sine squared theta. Okay, so if you can spot what I've done there, so basically I've factorized it because it's the difference of two squares. Well, we've then said that that equals 1. So I can then say that the first set of brackets, is just getting multiplied by 1. Yeah, because that's out. So we don't need to sort of justify that identity. We just need to spot where to use it. So that, oh, definitely don't do that though. That would have lost me the marks if I hadn't spotted that. So that can just be cos squared theta minus sine squared theta. Now, this is quite a general question. Normally in an identity, you'd expect to be sort of, that they'd give you what you needed to write it as, because there's a few things I could do there. I could substitute cos squared theta for 1 minus sine squared theta. I could substitute sine squared theta for 1 minus cos squared theta. I could factorize this, but there's not really an indication as to how they want me to give this answer. So well, let's just see what they've gone for. Yeah, okay, so they've left it like that. But you'd expect, if we're thinking about exam questions, you'd probably expect them to tell you what form to give it in. Now, if you didn't spot that, we'll spend a bit longer on this question. So let's say you didn't spot that, and let's go back to this. Well, your other option would be to say that was the quickest way to do it. So if you did spot that, that's your best bet. But you could say, well, cos to the power of 4 is cos squared squared, and the same as sine to the power of 4. And then, and again, you'd really, normally you'd expect the question to tell you how they wanted their final answer. Because what I could do here is I could say, well, cos squared is 1 minus sine squared. And then in fact, I'm actually going to rewrite the sine squared back as a power of 4. And then I could say, well, 1 minus sine squared all squared is that. And then if I multiply these brackets out, let's have a look at what happens. But like I said, you'd really need the question to tell you, normally you'd expect the question to tell you what form to have it in. But what you're really trying to do is just show that you know these identities and you know how to use them. So the benefit of doing this, if you did get a bit stuck, is, well, if you can rewrite it as cos squared, then I've used this identity here. Yeah, I've rearranged it to say that cos squared is 1 minus sine squared. So I'm just proving that I do know what the identities are. Okay, so let's just finish this one off. So if I square those brackets out, I've got 1 times 1. I've got sine squared theta times sine squared theta. Sorry, I'm skipping. I've got 1 times minus sine squared theta twice. So minus 2 sine squared theta. And then I've got sine squared theta times sine squared theta. So that's why I rewrote, I actually left that as it was in the original question, because now those last two terms you can subtract and just be left with 1 minus 2 sine squared theta, which looks different to what we got the other way, but actually it isn't, because if I, so if I go back to the other one, if I said, well, cos squared theta is 1 minus sine squared theta, then I would end up with the second result. So like I said a few times, you'd need the question to tell you how they wanted their final answer. Okay, let's have a look at B. So I think the thing with B, yeah, so what they're getting at with B is that these identities work even if it's not just x or theta. So don't get put off by these 3 thetas. As long as they're all 3 theta, then you can still use the identities. So what I can do here, so again, there's a few sort of variations on how I could tackle this, but what I'm spotting, so I would say there's 2 options. There's either thinking about using the identity, so saying that sine squared 3 theta is 1 minus cos squared 3 theta, but I'm thinking that's actually going to get quite complicated. So the other thing I can spot is I've got a common factor of sine squared 3 theta. So if I factorize, if I take sine squared 3 theta out as a common factor, I'll be left with 1 minus cos squared 3 theta. Yep, all I've done, so I had 2 terms. That was my first term, and that was my second term. So I've taken cos squared 3 theta out as a common factor. So that's something you've been doing, you know, for years now, but it just looks so much more complicated because of all this 3 theta and all this trig. Okay, right, so the other thing I can then spot is, well, think about the identity. So this identity, I'll write it with 3 theta because it still works. So then, if I wanted to make sine squared 3 theta the subject, I can minus the cos squared 3 theta. So that is actually, so I've got the sine squared 3 theta that I took out as the common factor, and actually it turns out that those brackets also equal sine squared 3 theta, and then here they're just testing that we know sort of how to simplify. So I'm not going to start multiplying 3 theta by 3 theta. That's not going to be relevant for this question. But I am going to say, well, sine squared times sine squared is sine to the power of 4. Okay, so that angle is not going to change because I'm not multiplying 3 theta by 3 theta. I'm multiplying those 2 things together. Okay, and I'm assuming that's how they left theirs. Yeah,